We are going to be looking at a question under heat quantity, the quantity of heat that a body possesses, or the quantity of heat a body receives or can give out. Or let me put it this way, the quantity of heat a body can lose and the quantity of heat a body can gain. Alright? Say that the heat quantity of a body depends on three major things: the mass m of the body, the specific heat capacity of the body, and the temperature change that body undergoes, moving from a lesser temperature to a higher temperature. So this is the amount of heat a body can either lose per time or that particular body can gain per time, giving us MC delta T. Alright, so if we consider this question with us, two objects are placed in consideration. It says two objects P and Q of the same mass. Now, if we say that the two objects have the same mass, therefore means that the mass of object P is equal to the mass of object Q. Alright, that's the first information that we have gotten from here. Okay, P and Q of the same mass are supplied with equal amounts of heat. So it means that these two objects, they were supplied with the same amount of heat. That is, the heat supplied to P is also equal to the heat supplied to Q. Alright, so that's the second information from here. They are supplied with equal amounts of heat. Now here is the question proper. It says the temperature change in P is twice that of Q. The third information that we can draw out from this is that delta Tp, the change in P, is twice that of Q. So delta Tp is 2 times the change in Q. That's the third information. Alright, so this is the first information, the second information, and then the third information. Then I say, what is the ratio of their specific heat capacities? What is the ratio of their specific heat capacities if they are supplied the same amount of heat and if their masses are equal? Alright, so that will mean that the heat supplied HP to object P is equal to the heat supplied to object Q. If HP, that's heat supplied to object P, is equal to mass of P times specific heat capacity of P times change in temperature of P, and then I have that HQ is equal to mass of Q times specific heat capacity of Q times change in temperature of Q. If that is true and my heat supplied to P and heat supplied to Q is equal, it therefore means that mass of P, specific heat capacity of P, and the change in temperature of P would be equal to mass of Q, change in temperature of Q times change in specific capacity of Q, or specific capacity of Q times the change in the temperature of Q. Now let's go back to our question. Mass of P is said to be equal as mass of Q. So anywhere I see mass of Q, I'm going to place mass of P, and I'm also told that the change in temperature of P is equal to 2 times the change in temperature of Q. Alright, so anywhere I see delta Tp, I'm going to put 2 times of delta Tq. Alright, so this will be mass of P, specific capacity of P, then here will be 2 times change in temperature of Q, because that's what we see here. This will be equal to mass of Q. Now will be represented as mass of P, because mass of P from the question is equal to the mass of Q. Right? So specific capacity of Q times change in temperature of Q. Okay, now since mass of P is the same as mass of P here, this will cancel out, and since I have change in temperature of Q here, this will also cancel out. So I am left with 2Cp being equal to Cq. And my question says find ratio of P to ratio of Q as regards their specific heat capacity. Alright, so this, if I solve this, I'm going to get that Cp over Cq is equal to 1 over 2. Alright, so this is the ratio. Therefore, the ratio of specific heat capacity of P to specific heat capacity of Q is equal to 1:2. So here is our answer. I want to believe this is very understandable, but then if there is still a gray area that is not clear, you can drop the question in the comment section.